Hi, Assalamualaikum. In this video, we will discuss about evaluating inverse trigonometric functions using triangle method. Alright. From the previous video, we have been discussed about introduction containing notation, properties, and the graph of inverse trigonometric function. Alright. So now, we continue with Topic 2, which is evaluating inverse trigonometric function using triangle method. Alright, now we look at the procedure to evaluate inverse trigonometric function using triangle method. Okay. Alright, step 1. Okay, we let A equals to the given inverse trigonometric function. If we have two inverse trigo function, we can let A equals to the first inverse trigo function and B equals to the second inverse trigo function. Alright. Then step 2, we need to change the inverse trigo function to ordinary trigo function. Right? And then step 3, we need to draw a right angle triangle and then we need to determine all the sides based on trigonometric function obtained in step 2 here. Okay. Step 4, we need to find the relevant trigo ratios from a right angle triangle obtained in step 3 here. Okay. And finally, step 5, we can evaluate the given question and then we can refer useful formula that we will discuss later. Okay. Here are some useful formula to evaluate inverse trigonometric functions. Okay. Angle sum and difference identities. Okay. Here we have sine A plus minus B, cos A plus minus B, and tangent A plus minus B. Okay. Sine A plus minus B equals to sine A cos B plus minus cos A sine B. Okay. Plus minus here means if we use plus sign in bracket, so we can use plus sign here, okay, for the right side, okay. And if we use A minus B, so the answer equals to sine A cos B minus cos A sine B, okay. If we have cos A plus minus B, it is equals to cos A cos B minus plus sine AB. Minus plus here means we can use opposite sign. Means that if we use A plus B, means the answer equals to minus sign here. Okay, if we have cos A plus B, so it is equals to cos A cos B minus sin A sin B. And if we use formula cos A minus B, so it is equals to cos A cos B plus sin A sin B. Okay. And then the third formula, tangent A plus minus B equals to tangent A plus minus B over 1 minus plus tangent A tangent B. It means that if we use tangent A plus B, means the right side should be tangent A plus, we use the top sign, okay, tangent B over 1 minus tangent A tangent B. And if we have tangent A minus B, so we need to write tangent A minus tangent B. The sign for denominator, we just follow from the sign in bracket here. Okay. And then the denominator equals to the opposite sign. Okay. So if we use A minus B, the denominator should be A plus tangent A tangent B. Right? But wait, there is more. Okay. Now we look at double angle identities. Okay. We have sine 2A, cos 2A, and tangent 2A. Okay. 2A here means double angle identities. Okay. Sine 2A equals to 2 sine A cos A. Okay. And then cos 2a, we have three formulas here. Okay. First, in terms of cos and sine. The second one in terms of cos only. And the last one in terms of sine only. Okay. The first one, we have cos 2a equals to cos squared a minus sine squared a. Cos 2a also equals to 2 cos squared a minus 1. And cos 2a also equals to 1 minus 2 sine squared a. Okay. Alright. Tangent to a equals to 2 tangent a over 1 minus tangent squared a. Okay. Alright. Alright, now we look at the other formula that useful to evaluate inverse trigonometric function. Okay. Reciprocal trigonometric identities. Okay. Sin A equals to 1 over cosec A, or cosec A equals to 1 over sin A. Okay. And then we have cos A equals to 1 over sec A, or sec A equals to 1 over cos A. Okay. And we have tangent A equals to 1 over cot A, or cot A equals to 1 over tangent A. Right? And then we look at the Pythagorean identities. Okay. Alright, cos squared A plus sin squared A equals to 1. Okay. From here, if we dividing each term by cos squared A, okay, we will get 1 plus tangent squared A equals to sec squared A. Okay. And if we dividing each term from here by sin squared A, so we will get cot squared A plus 1 equals to cosec squared A. Alright. Alright, more formulas. Okay. Quotient identities. Tangent A equals to sin A over cos A, and cot A equals to cos A over sin A. And the last one, opposite angle identities. Sin negative A equals to negative sin A, cos negative A equals to positive cos A, and tangent negative A equals to negative tangent A. Right? After we discuss the useful formula to evaluate the inverse trigonometric functions, coming up next, we can discuss examples involving evaluating and simplifying composite inverse trigonometric function using triangle method. Okay? If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.